Okay, it looks like we're live. So let's get right into it. Gonna be continuing to work on the compiler today. Here is the code. I will put it in the chat for anyone who's interested. So I worked a little bit with it off stream. Let's see. So basically, what we've got right now. We'll get to this. Right now, I reconfigured the expressions so that it's more efficient. And I also fixed a bug where it was reading one character too far, so we were getting unwanted data and it was causing compiler errors. So, yeah, the expressions should work pretty good now. So I write that. Let's build it and make sure it's working. And we run this. 15. Alright, that's perfect. Basically, the changes I made, if I open up code generator, so down here, we can see I added operator type, which we evaluate right here. So basically, we pass in a node, and it returns not an operator if it is not an operator node. If it is, we check the value, and if it is plus, then we add sub, and then this will be easy to implement more operations as we need them, like greater than and such. And then return not operator if we reach the end. Yeah, even though we do check that up here, but just to make sure. So if we go down here, already. So I implemented this as well. Basically, it just checks if it's an identifier, and then it moves into the register based on the value. Otherwise, it moves like this. So we use that instead of move whenever we have a variable that we need. So, yeah, so here, I completely revamped this, so now it is much shorter. As you can see, it was like 200 lines or something before, and it was very inefficient. Now, basically, we move the value into racks, and we push it, and we set the temp, and then we get the operator type, and then we iterate through. We pop racks, because that's what we pushed up here, and then this is just for the loop. We get the operator type again, and we set it to the right. And now it goes through. Before we were checking if the right node was an operator, and that wasn't very efficient. This way we can do this, and then we just check and we generate the proper code if it is, and at the end we have to do this because we end on a node, and then we just have to check the operator type. Yeah. So yeah, it's much shorter, much more concise now, and it works a lot better. That's all I changed basically. So let's see. So today, if statements, that's what we're going to be doing. So let me open up the generated.assembly. We can get rid of some of this. So how do if statements work? Basically, we need to know about labels. Label, basically just an identifier that keeps track of where a line is in the assembly that you can call to and move to if you if you call to it with the right I don't know what it's called, with the right like function, basically this. So what we can do, for example, we can move RAX, we can move 1, we can move RBX 2, and then we use the jump operator. No, we don't use jump. We use J, which is jump, and then if it's equal, then we will jump to, we'll actually call it continue instead of label. So I'll put continue down here. So that's the label that we jump to. If they are equal. So actually I have to compare it. I forgot. This is the actual if statement part. So we compare it, and then if it's equal, we'll jump to continue. If they are not equal, then we will, let's move RAX 27, and then push RAX. So now, if we build the assembly, as long as I didn't mess anything up, it should, actually we didn't push anything here, so let's push RBX, and then it'll be 2, so it should exit with 2. 27, okay, so actually I messed it up, okay, yeah, so if they are equal, then we skip this. If they're not equal, then it will go through this. So like we can change this to J and E, which means J, or jump if not equal. Then it's 2. So basically, this would correspond to something like if x equals 2, and well, x equals 1, and then y equals 2. So if x equals y equal y, let me see. So if they're equal, alright, so it's actually not equal. X does not equal y, which that doesn't count it. But if it's not y, then x equals 27. Basically, is what we're doing. And then we exit with x. That's basically what we're doing. Something like that. So you can get an idea of how we would build this. So what we could do, whenever we have the closed parentheses, we can generate a label here, which it'll probably just be something like label 0 and then iterate it each time. Probably. Yeah. So you can see how that would work out. So let's go to the Lexer. Whoops, I didn't mean to do that. Lexer. And let's just add if. Alright, so let's do in here the keyword. You're generating a keyword. So else if keyword is if equals 0. Whoops. And we can just put this right here. Token type equals keyword. Token value equals if. Okay, so now we should be able to generate the if keyword. So if we open test.un and we do if x equals equal example. Alright, so this should work. Let me open main. May not see, and let's just test the parser. Or the Lexer. Excuse me. So we'll do this. Okay, let's build this. Alright. So it does not work. Oh shoot. Oh. Here's how I need to print these. That's probably a good idea. So we can actually see what we're working with. Okay. So, if is the keyword, and then, yeah. Alright, so this is good. So something we probably need to do is, should we do this in the parser? I don't know, we'll get to that. But yeah, so this should be working. So we should be able to generate something from this. So, let us generate the parser now. Parser f.c. Alright, so let's see. So if we encounter a token, I need to clean this up too. This is a bit messy. Let's see. All the way down. Holy moly. Yeah, there's a lot in here. Alright, this is where it is. Case keyword. If current token value is if, then equals create if statement. Alright, so we will create that. So I will put it, let's put it right here. Let's see. Node create if statement. And it takes that token, and node current. Believe that is correct. Yep. Okay. So we can return current, and we will modify it in. All right. So let's see. So we know that we have the if. So we can actually iterate here. Yeah. Well, no, because we need to generate the node. So let's generate an if node. So that's going to be just a keyword. Node if node equals malloc size of node, and then if node equals init node, if node current token value, and it is a keyword. Okay, so that should create the word, and then we'll set current left equals if node, and current equals if node. Okay, so now we need to think about what's going to be in the parentheses. So it could be a number of things. So it's going to be either an identifier or an integer. And then for now, I'm not going to handle something like this, which would generally be, if it's anything other than 0, then it evaluates as true. We'll do just something like this. So equals 9, right? So basically we need to evaluate the 1/2 of the, let me think, 1/2 of the expression. So, because it could be x plus 3 equals 9 minus 2. It could be something like that, right? So we need to evaluate both sides. So, let me see, I think, alright, let's do current token plus plus. And then I think that we have like create variable reuse. That's not what we alright, I guess I'll have to re-implement it. Cause yeah, he's gonna, alright, let me go back down. What was it called? Create if statement. Okay. Current token plus plus. So we want to make sure handle token errors. Error expected identifier or and then also I need to pass. What else do I need to pass? What else? Current token and current token and actually that's not gonna work because I don't have that function set up right. So let's just do if current token type does not equal identifier or current token type does not equal int. Well, I guess and. Then we will print out error expected identifier or int. And we'll exit one. Okay, so we've got that. So now we know that this is going to be either an identifier or an integer. So then basically we can just, we'll make a function that takes the node and it create, yeah. Let's set current equal to generate operation. Oh shoot, actually that might work. Operation. Yeah. Ooh, okay. Yeah, it needs to start on an operation token though. So we can do that. Let me see. Let's get down. Alright, right here. Alright, current token plus plus. Current token type is not equal operator. Then we will error expected operator. Exit with that. Okay, so then we can pass the current token in the current node, and it should generate the first half. The problem, alright, we need to check if it's an equals. Well, let's see what this generates now. So if we, let me see, did I modify it? Yes, okay. I build this, Alright, sign it from node to token. Okay, so that's just gonna you said the current token to that thing. Well, alright. Selected identifier or int. Let's see. Alright, so I think that is printing from here. Alright, let's see. Let me see. Current. Oh shoot, you know what? Because we need. I forgot about the separator, the brackets. Do we need that? Let's try it without them actually. And it breaks. Alright, let's do this and let me see. So let's do that and then current token type. What do I need? Let's see. And it should be a separator. Shoot, actually, no, we just want current token. And then we also want to pass the message. Error expected that. Okay. And then we'll generate the node for that. Node open paren node equals now size of node. Then open paren node equals init node. Open paren node current token value and separator. Node. Well, alright. And then we want to set current left equal to open paren node. And then current equals open paren node. Okay. Now let's see what happens. Okay. Oh yeah. And then we have to iterate actually. Current token plus plus. Alright. Segmentation fault. Alright, so I'm assuming that occurs in here. Oh, it's probably reading something out of bounds. Let's make sure. Made it here. I messed that up very bad. Made it. Alright, and it should just print one of those. If that's where we. Yes. Okay, so that is the problem. It's in here. So let's go to generate operation nodes. And let's see why that would cause an error. Okay. Oper node. Okay. Current token value. Alright, so we don't even make it here, so... Ooh, okay. Current node, left. So, let me draw this, so I can illustrate what is happening. So, let me zoom out a little. Basically, I made that way too big. We have the main program. Go off to the left. We've got the if here. And then the left of that is open, I suppose, and then this will be closed. And then here we have x. So do we want to pass it? Do we want the current node to be equal to the open parentheses? Is it actually? Let's see here. Okay. So it should be current equals open parentheses, because then to the left of that, it should generate equals. Alright, well let's generate it operation, and we'll just make a new function for it. token generate if operation nodes, and we will take current token and node. Okay, so let's see what we need to do. So, oh shoot, actually the problem could be because we are, let me try this actually. Generate operation node, because we are already assigning it here. Well, no, actually, never mind. Let's go here. So we are on the operator. So let's make node oper node equals malloc size of node. Yeah. And operator. Okay. And then we'll do current left. Is that? We want current left to equal oper node. Because we don't actually, we want this to be equal. And then we have the two sides, right? We have this expression and these here. Right? That is what we want to check actually. So yeah. So the left will equal the operator node. So we want this to actually equal double equal. So what we're gonna do, let me see. Let's do current token plus plus. If current token is not equal operator, then error expected operator. Okay, because basically what we're going to be handling right now, we'll have equals, or we'll have not equal, something like that. And we can just set the exclamation point to be an operator. We don't handle that yet, but we can get there. So, alright, so as long as it is, then we're good. So then we need to basically put the strings together. So can we do something like char operator node value malloc size of char times 2, because it's gonna be 2 characters. Well, we should do 3. Well, we'll do 4 because each one's gonna be 2 characters long. So we need to concatenate them. Well, actually, trying to think. Well, let's try operator node value equals s_printf. So I think we can do this. %s basically, and then we take current token and current token minus 1. And we can set the value to be operator node value. So let's see if this actually works, because I don't know if it will. So I think we get here. Okay, we have some problems. Oh, that is an error. We need to do that. Alright, let me look up. Well, actually, I think we can do man. Alright, let's see. I want this one. How do I get to it? Let's. I don't know how to view the next one. Alright, let me quit out of this. And I'll open it up in here. Man3 s_printf. Okay, here we go. Alright, s_printf. So it returns an int. So maybe that's not. Shoot, actually. is this what we want? Operator node value. Okay, we need to do current token value. Current token minus 1 value. Maybe that will work. Let's see. This needs to be current token type. Alright, it reaches the end. So yeah, let's just return current token for now. Alright, let's see. Alright, and it just stops here. Oh shoot, actually it did generate stuff. So we have if plus x. Alright, so that didn't work. Alright, but this did work. So it did concatenate them to be equals equals. So problem is after that we just don't set it properly because we go back over. So current left equals operator node. Okay. So that should set the value properly. And actually just to make sure, let's get rid of this. No, not that. And then we'll do current equals operator node. And we'll printf operator node and then current value. And we'll see what this says. Alright. That did indeed work. So now we can go beyond this. So what do we have after that? So then we need to handle the left side and the right side. So should we use, let's see, basically what we need to do is anything, actually let me go back down here. So here we have selected that. Alright, actually here we want to do, wall current token type does not equal operator. Then we want to do that. Because then that guarantees that we get to the operator. So we don't technically need this. Actually let's do and current token type does not equal end of tokens. Just to make sure. Alright. So then we basically look at everything before it and generate the corresponding nodes. So let's see. So we would want, how would we want that to look? So we have the equals. So let's say it is x plus 3 equals y minus 2. Something like that. So that'd be actually, so then to the off to the side, it would be something like this, minus and plus x and 3, right, and then 2 and what, or I forgot what it was. Yeah, so that's basically what we're gonna do. So we need to string compare actually. Current token value equals. Let's see. I'll make it that. Okay. So now current token plus plus. Okay. Then we should make sure we get to it. So yeah. So if we have x plus 3. So we want to look on the left. Let's see. I suppose how we could go about doing this is using a while loop. We do while current token type does not equal separator. We could do current token minus minus, right? And then we do current token plus plus because we reached the separator. So let's also do and current token type does not equal n. Well, yeah, so we shouldn't need to worry about that because we do get to it. So I don't think we need to handle that. So then we go to the next one, right? So that would put us at x, for example. So let's see. So we are at the first identifier or integer. Then we need to go to the next thing and generate the operator node based off of that. So current token plus plus, and let's do if current token type does not equal int and current token type does not equal operator. No, not operator. Identifier. Then we'll printf error expected int or identifier. I can exit with 1. Now we'll do current token plus plus because we know that it's that. Then if current token equals equals an operator and current token value is not equals, because if it's equals, then that means we just went back to what we were at before. Then we will do this. So that means we reach an operator. So we will do node trying to think. Node operator node equals node side of node. The node equals init node token value and operator. And then let's see. So current node is that. So current left equals operator. All right. So we handle the first one. But we could have infinite there. So let's look at how we do that up here. Let's see. Operation node. Anyway, all right. So let's see. Upper node. Okay, so we just checked the whole thing. So I think we can do that. Alright, so let's go here. So we'll do let me see. Otherwise, if we reach the equals, then that means that that's the entire left-hand side. So we'll do current token minus minus. And then we'll do node, extra node equals malloc size of node, extra node equals init node, and token value, and int. Well, so we want to do int if current token type equals int, then we do this. Otherwise, we do identifier. Alright, let's actually go up there. So let's see now. Actually, let's generate the... What? No, because we're not going to do that. Oh yeah, I forgot we need to do current token type. Okay. So, expected operator. Alright, that is right here. Okay, are we skipping just to the end? Equal operator. So I don't think we need to do that. Okay. So let's see. So we still so let's just close current node. Equals not size of the node. So we'll do some checking afterward, but close current node, init node. And for now, we'll just do that, and then separator. And then current right. No, actually. Yeah, because this is just operator. So actually, we want to do this equals close. So we want to do this. Let me get rid of that. Put it down here at the end of this. Okay. Actually, then we want to set current equals close. Alright, there we go. Now we have the equal. So if, and then let's see. So this should look more or less like this. So if, and then open current node, and the right of that is close. Alright, so we just generate the equal right now, but that's okay. Because we're going to generate the rest. Actually, so yeah, if I go in here, it should generate the x. No, it just gets equal. Alright, so that means I messed something up, but we are close. Alright, let's see. So where are we setting that? That is handled down here. Alright, let's see. So where? So here. I think what we can do is actually do current token minus one time to make sure we are out of the equals. Ah, dang, that didn't work. Why did that not work? Let's see, why did that not work? So here, Let's see up here. Do we need to go back twice? We should. Okay, so that is not the problem. Current left equals upper node. So, let's print out current token value, and we actually have to current value is that. Alright, let's see what this does. Equals X. So do we not need to do, we should need to do that. Okay. Ooh, okay. That's, no, that. If current element type equals operator. This should be that. Okay. Let's see. Actually, we want to do this. We can switch these, cause so if it's operator and that. Yeah, let's take this actually. Place it in here. And we'll take this and place it here, and we'll put it in else if current token type equals operator. Then oh, we never actually set it. So current left equals X. Okay. If X, and then if we set the right to the next one. So if we go through this, then we'll have generated everything there. We have not yet when there's operators, but we will get to that. So now, let's do current token plus plus. Let's see, so that's gonna put us at the equals. It should. And then current token plus plus again. And we'll do it one more time actually. Current token plus plus. So then we'll do if current token type equals operator and current token. So I think we can do basically the same thing we're doing here. Okay. No, not exactly. Type equals operator, then we'll do this. Type equals separator. Then we'll do current token minus minus. That should hang on. Current right. Okay, so not exact. Let's see. So we are here, and we are at the operator node. So that is me. Oh shoot! Actually, we're here. So we're at the expression node. Then we go to the next one, but then we have to handle the equals as well. Equals. I think we might need one more of those because of the double equal. Okay, Yes, so now this looks like this is 9 and that's x. So that's good. So I think this is basically, alright, if we actually add in here, if we add something in here like int x equals 12, right, and then we build this, then that is contained within the parentheses. So that's good. So that's in the scope. So this is just about what we want. Okay. So let me see. So now we need to basically just generate it if there is operators. So let us do that. We'll do it on the first one first. So let's set this to be x plus 3. Then we need to parse that. So alright, current token value operator. Yes, that sets it to plus. And then we need to do current token minus, and we want to go down here, node equals node. Alright, so that can be in or. Could be in or identifier. So if current token type equals int, we will do this. Else, if current token type equals identifier, then we will do basically the same thing, but set this to be identifier. Do we? I don't actually. Now that I'm thinking about it, we could do this instead and just do current token type. That's probably a lot better. Okay. Then the left is expression node. And then we want to do current token plus plus, current token plus plus, and then that should put us at another one. So let's actually while current token equals operator, or current token equals int, or current token equals identifier. How many are there? Okay. So if, oops, gotta spell this right. Operator. Okay. If current token type equals operator, then we want to do that. We want to do minus minus. And then if current token type equals int, or current token type equals identifier, alright, but that is just on the left side. So perhaps what we should do, size of node, and then temp equals current. And instead of this, we can do temp left. That's saying the off node. So let's see. Actually, so if we do this, let me try something. So let me grab all of this. And we'll place it up here. Okay, whoops. Alright, so now, like this. Now what we've got here, so we set the left, and then we set the left of that, and then in here we want to just consistently be setting it to the right, I believe. Because then that would generate something like this, right? So we have the plus, and then x over here, and to the right of that we have plus again. Actually, so we do want to set this to be left. So we could probably place this in here. So we might not actually need this one. No, because then we'll generate a second operator node. Will we? Alright, well let's see actually what this does at the moment. Alright, whoops. Current token. Where is that? 541. Type. Okay. Alright. Temp is undeclared. Oh yeah. Set this to current. Alright, and then it breaks. So let's see why that's happening. So okay, so if it is operator, we do that and we go minus, and we set this and we go plus plus, and then it should be another identifier. So we go through here. It is an identifier. Then we just want to plus one time. Okay, let's see what we generate. Not right. Okay, it's not right. Let's see. What do we have in here? Alright, it should be x plus 3, and it's just x. Wait, that's not right at all. Okay. Let me see. Whoops. Let me zoom out a bit. That makes it look kind of weird. And I've got something very strange there. Okay. Let's go generate operation nodes. Okay. let me try this again. Alright, let's do... Whoops. Alright, whoops. Alright, yeah, so this is not what I meant to do. Value. Alright, let's... Alright, so it breaks. And let's take a look at where it breaks. So it breaks before this. Yeah, alright, so it's the problem with this. Setting left equals to upper node. So I think that's where it broke. If I do that, alright, so it's fine there. Yeah, alright, so that's where it breaks. So alright, let's see. Current equals opening paren now. Temporary, let's do current open minus current dip in minus 1. And that will put us, yeah. So with this, we have something like that, and x. So what if we don't do this? Okay, let's see. Alright, so we're at plus. So let's go to generate operation nodes. Okay. Alright, so here let's actually do if current token type equals if this actually value okay. So that actually generated mostly the proper thing. So now basically we just need to generate the, let's see if it works with more than that. Let's see, in here, what if we just do X? Would generate that? No. Okay. No, and that doesn't work either. Okay. Dang. Alright. Dang. Let's get rid of that we did there. Alright. We'll return that to how it is. Let's actually copy this though. Then we'll basically modify it to work with what we need. So yeah, we can actually use that to replace all of this. We'll just get rid of this entirely. Alright. Back to square one. Let's see. Let me build this. Alright, we do have some problems. Current. Alright, yeah. So let's just change this to current node. And then that will fix a lot more. Okay. So when we're here, we're gonna be on an operator node, like plus or whatever. Okay. Let's get rid of that. Okay. Alright, so we're at plus, and then we go back. Then we generate this. Then we go plus, and then go plus again. So then we'll be at the 9, right? And then we'll do this. And then this should work about the same as how that was. So okay. Yes, we have the 3 and the 9. that's not right. Yeah, okay. So actually, yeah, we want to break if that is the case. Alright, then we don't get the X though. So why would that be? Because that should be handled here. Here, well, actually, we can take this. Alright, let's make sure. Spin mode valid. 3. Okay. Oh, okay, so that is the problem with down here. Oh, alright, yeah, so that is just the problem with what we have here. So instead of this, we'll do print token plus plus. We'll just try that. Alright, length is plus. Okay, so that's almost right. We're just missing the 4. So why don't we get the 4? So we get it for 3. Yeah, so we need those. Alright, so we do get the 4. So we get here, and it's 4, but then we go past it. Oh, okay. Do this and get if token type equals then we'll just current token length. Alright, this might actually Dang, alright. This is taking a lot more time than I thought it would. Okay. So that is what we want actually. So let's make sure we can do +5 +6 and like that, and it generates the whole thing. Okay. And we can throw in a division there. Whoops. Alright, yeah, so that's looking good. Now we can also handle this. That actually seems to work. Okay. So now we basically need to generate the equals and then run it through the same function, I believe. So after let's print that token after it is that, and we'll see what it is. Current token type per value. Alright, let's see what that is. Token after if is equals. Okay. So basically we can just start from there. So let's see. If current token type is not equal operator and value is not equal 0 and error expected that. Sure. Okay. So now we can create the equals node like we were before. Where, let's see, equals offer value equals malloc size of char times 4 like that. Well, and we can do and then we'll do current token +1 value. Like that. And then we should be able to print f equals offer value, and it should be equal. No. Alright, so we'll yeah, so let's do -1x. Okay, equal. Alright, so that's good for now. So get rid of that. We'll do current node. Well, no, it's just current, right? So we are at the open. What is the current thing? We just do open current node right equal. No, that's not what we want. So we might actually want to generate this before. Yeah, because if we want it to be like this, then we need to generate it before. So let's do that actually. We'll move it up here. Then we can do this, generate that, and we'll do so how we want it. Yeah. Alright, yeah, I actually want to do node equals offer node, like size of node. Value and operator. Okay, so then we set that, and we instead of plus plus, we want to do minus. Actually, here we can do. Alright, something like that. Alright, and let's see. Alright, so that, no, because it didn't set the, dang it. I think we actually want to do this, yes. Almost got it. This can be plus 1. Okay. X plus 3, and if we do plus 4, that should still work. Yes, and if it's just X, it should also work. Almost worked. Dang. So in here, we need to fix that. That could be. Okay. Ooh, okay, because that's just because we need to handle that. Node node equals node size of node. Node equals init node. I actually want to do node export node current token value and then current token type. Okay. Okay, and we just need to make sure it still works with this. Yeah, so that's looking good right now. Now let us generate let's see. So then here we want to do wall current tokens not equal end of tokens. Current token type does not equal operator. Current token plus plus. And we'll do actually current token plus plus one time to get away from that. And then we should be able to do current token equals generate if operation knows current token current. Okay, so we need to change the current. Okay, yeah, I need to actually rethink this because we want to set it to the right when it's on the right. Okay, equals, right, it's equal, equals not, okay. Right, so there are some problems in here. So why is this getting placed on the left here? Oh, hey, we actually have to set this. Okay. Okay, left is that, right is, alright, so that is looking pretty good. This probably won't work though. We didn't handle that. Yeah, okay, but we can handle that if we so we can handle that if we oh shoot, we actually skip a lot here, so this is a problem. Let's see, so if we do current token plus plus from here, so we do that, and that leaves us at equals or current token plus separator. Alright, so then that breaks it actually. Alright, so then we can do if current token is separator, then we can do current token minus, and then we generate this. Else, we can generate this. Okay, that looks good, and let's make sure this works. Alright, that's 3. Alright, so that looks pretty good, I think. So now, let's try to generate this. So if we go to our code generator, alright, let's go down to where we are handling everything. Generate code. Alright, in here, actually it's up here, where we have the keyword. If, or no, value is if, then we want to do, we want to check if the next one is an open parenthesis. Well, no, it should always be an open parenthesis. So basically we just need to evaluate the expression within and then do a comparison on it. So if we do in here generate operator code, let's try just running that. Generate operator. Oh no. So actually we can do current equals node left, and that'll be the open parentheses. And if we do node left, so that is the equal. So to the left of that, we have to evaluate that. So let's do generate operator code current left. Then generate operator code current right. And then compare. Let's see, I don't know if that will work, but we can see what happens. Alright. Oops, I forgot to fire out the file. Alright, and we need the, let's see. We need the file. Alright, what is the current then? Alright, we'll be back. Alright, and actually we do need to change this so that it is not like that. Alright, and it worked. Okay, let's see. If, where'd it go? I'm in the wrong file. Okay. Alright, let's see where it breaks. Here and here. Let's do that. And then put it down here. I have a feeling it breaks in the generate operator code. Yes, okay. So why does it break in there? Alright, generate operator code. So node, oh, so it wants us to push it from node left. Alright, let's actually let me see. From the operator. Because there is no no addition here. So let's actually, let's change that. Let's do plus 3 plus 2. Alright, then what does it do? X not declared. Alright, yeah. Then x equals 9. And we'll get rid of that. Alright, and it breaks. Actually, let's go back down to here. Alright, well, we don't even do it twice. Okay. Alright, where is... Alright, so that's the problem. So let's just return 3. Okay, and let's see what it generates. So, compare them. Alright, and then let's actually do jump if it's equal. to test, and we'll just make a test label. Alright, test. Otherwise, we will do move RAX 60, move RDI 12, and then syscall. Alright, so let's see. Alright, so it is not equal. So what are we doing in here? So is it evaluated properly? Alright, well we can actually find out if we do like that 2. And then we do basically the same thing that we just did. Do that. And here we do turn that equal test, and move RAX 60, move RDI, RDI 12, alright, and now let's 12. Alright, so it does not work. Okay, let's see. Add RAX, RBX. Alright, so we need to, I think what we can do actually is just pop RAX, pop RBX. Alright, now let's try it. .sh. Alright, so this isn't actually going to do anything now, but this should be better. So after the compare, we do jump equal test. Alright, and move RAX 60, RDI 12, syscall. Alright, let's see what happens now. So build assembly 3. Okay, so that worked that time, but alright, let's just try. Let's change this to 3. Then it should not work. Do that, and then we have to change it all. Test. Move RAX 60, move RDI 12, syscall. Alright, and now build assembly, which should 12. So it's not equal. So that actually is what we want. So we do want to do this actually the opposite way. So yeah. Alright, so now what we can do, we can do fprintf file jump not equal to that label, right? And then what we can do is on the close parenthesis, which is handled here, or close, not parenthesis, curly, on the close curly, we can do fprintf file, and then label, and UI. So then we build all this. And let's see. So now we have a label. Alright, actually I want to move that to the top of the function because, well, no, do I want to do that? Yeah. Well, no, actually that doesn't matter. No, I'll do that. build this again. Right, and then we have the label. So now what we want to do is evaluate everything within there. Yeah, alright, we don't have anything in there now, actually, so let's do that. Int x equals 3. Let's try that. Whoops, I didn't do that. Okay, x is alright. We can get rid. Well, no, we'll make this y. Okay, now in here, push 3. Okay, so that's what we want. Alright, so now let's actually make a global variable, and we'll call it int label number, and it starts out at 0. And then we'll just make a function here, void create label, and it just takes the file. Actually, I need to make this file, and fprintf file label %d, and we'll put the current label and label number plus plus. Okay, so I think that's what we need to do. And then down here, all the way down at the bottom, when we have this, we can just do label create label file. And then up here, let's see, in here we can do equal label. Label number. Okay, now we build this, and that should label 0. Okay. Okay, and if we make this 2, and it should be equal, x is with 2. Oh my goodness! Alright, so it works. We do need to change it to be a little something like that, because that doesn't work right now. So what we can do, generate operator code. So actually, let's just do if current left equals int, or current left type equals identifier. Let's make this type. Then we will just do, let's see, what do we want to do? Do we just want to push it? Perhaps. Okay, then we can do the same thing here. Alright, so here I think we just want to do move is there or not, ix file, is that, I think that's what we need to push, and then we can just push, well no, I don't think we need to push it, alright, yeah, we'll push rx. And here, yeah, move there or not, rbx file. Alright, so actually we do need to provide, we need that. we need to provide, what do we need to provide? That, and then we need to do current right value. Alright, let's see. Alright, let me look at move if var or not. Alright, register node. Alright, so we passed the node, not the value. Alright, yeah. So just current node and current right. Alright, now do something. Alright, so that still is not working. Oh, whoops. So we need to check that. Okay. And then we do echo that 2. Alright. Alright, and that is right. But if we make this 3, it should be 3. Okay. So this seems to be working. So let's see. If we do 3 times 9. We do x times 9, and that should return 1, otherwise we'll just return 0. Alright, so that returns 1. Okay. But now we do plus 1, and it returns 0, but if we do plus 1 again, it returns 1. Okay, so we now have working if statements in the language. So that is pretty flippin' cool. Yeah, that's pretty cool actually. So while loops, I'll just talk about it for a second. It's gonna be a pretty similar thing, right? So I will actually go ahead and do this. Alright, just to clear it out a little. So basically while loops, we're gonna have the same comparison and the same jump. However, at the end, before the label, at the complete end of it, we need another, so actually we need to generate a label up here, something like loop 0, right? Loop 0. And then what we can do is we run another comparison at the end of it. So I need to think about how we would do that, but yeah, run another comparison, so like RAX, RBX, and then if it is equal, or jump not equal, loop 0, right? Otherwise it just continues on. So I don't know. Loop 0 not defined. Oh yeah. Loop 0. Okay. No. Alright, 1, it just runs 1. Yeah, but if we do that, I suppose. Alright, well, maybe if I clear all this actually, I can sort of demonstrate this a bit better. Alright, so we have the start. And basically we'll move RAX2. We'll move RBX2, right? And then we'll compare RAX with RBX. And then jump not equal to a different label, right? We'll just call it label. We'll make the label down here. And here we can just do move RAX60, move RDI2, or we'll do 0. And then syscall, right? And then in here, what we can do is add RAX2. And then add R, and compare, you can compare RAX with 8, for example. And then jump if not equal to the label. Right? I think something like that would, let's see. Alright, I messed something up. Oh, right there. So actually, let's move this RAX so we can get an idea of what it is. 60. Oh shoot. Okay, because we do this. So let's actually push RAX. Well, we'll push RAX here. And then we'll do pop RDR. There we go. Okay, now 4. Alright, so it starts at 2. We add 2. Oh shoot, because we jumped to the label every time. Because I forgot to add, we need the loop in here. Alright. And we want to jump to loop, actually. That is my bad. 8, okay. But, if we do, if we set it to, let's see. If we set these to be equal, well, if we set them to be not equal, it will return 3. 3, yeah. So there you go. So that is sort of, it's an if statement with an extra label and an extra check, basically. Well, actually, so I suppose the way we would do this is on the open parentheses after the while loop. We would do create the label, because this is sort of just an if statement before it, right? Basically, this is what we would want. This is never going to be true, actually. So if I build this now, so this is actually more like what we're going to have. So on the open parenthesis, or the open curly bracket, we would put a label that says loop, and then I guess just before the close one, if there was a while loop, then we would add this instruction, where we'd add the compare and that instruction, and then we would jump. So yeah, you can see how it's very similar to an if statement. Then once we do that, we're getting close to being able to implement FizzBuzz, which again is the goal, primary goal of this, is to be able to implement that. And then, yeah, then we can move on to some other projects. So let me actually push this. Implemented if statements. Needs some further testing, but seems to be working for the most part. Git push. Alright, yeah, so that is up on the GitHub now. If we look here. Yes, sir. Now. Alright, perfect. So, that's going to be it for today. Thanks for watching. See you next time.